numbers. So the complex number u is 3i over a plus 2i expressed in terms of a. So we want to realize the denominator. Just like rationalizing denominator, we want the denominator free of imaginary I. We do that by multiplying both parts of the fraction by the complex conjugate of the denominator. So we multiply by exactly like this, but instead of plus we use minus. Okay, now we multiply 3i times a, 3ai, 3i times minus 2i, we have minus 6i squared, and a times a squared, a times minus 2i minus 2ai, 2i times a plus 2ai, 2i times minus 2i minus 4i squared. I squared is actually minus 1. So minus 6, that's why we have plus 6. And minus 4, that's why we have plus 4. Cancel out minus 2i plus 2ai. Cancel out. So we have only 6 over this plus 3ai. So 3a over this times I. So this is the final answer in x plus yi form. Exact value for which the argument is 1/3 pi. So the u star is the conjugate of u. So if this is u, the u star is almost exactly like this, but instead of plus we use minus. So this is the u star, or the complex conjugate of u. So 6 over a squared plus 4, that will be around here, let's say, and 3a over a squared plus 4, because the angle is positive pi over 3, it's gonna be around here, up here, because the angle is supposed to be positive. Okay, so the angle is always from the positive real axis counterclockwise direction. So this means if we want to find a, we can use the fact that the tangent, if you look at this triangle, the tangent is this length opposite divided by this length adjacent. So this length is this number here, and this length is this number here. Okay, so notice that this value here must be positive, which means the a is negative actually. Okay, so we include the negative also here, we cancel out, and we simplify. This is actually minus 1/2 a, and therefore a is minus 2 root 3. Right, next part, locus. So the first locus is, we have the absolute value of z on both sides. This is a perpendicular bisector. So to identify the 2 points, we have to use z minus z1 form. So z minus z1, notice that without the brackets we should get exactly the same minus 2i, exactly the same minus 1 minus I. Right, so now we can identify the 2 points 0, 2 and 1, 1. We are drawing the perpendicular bisector between these 2 points, and smaller than means we shade towards the one on the left, which is 0, 2. So this is the sketch. 0, 2 is this point here, 1, 1 is around here. The perpendicular bisector means it is through the midpoint of these 2 points, through the midpoint, and it's perpendicular. So this would be the line, perpendicular bisector line. We shade towards 0, 2. So when we draw the perpendicular bisector, we're gonna need to label the x-intercept, y-intercept. Okay, so that's for the perpendicular bisector. And for the other locus, this is absolute value of z only on one side, so this is a circle. Again, we use z minus z1 form to identify the center of the circle. Radius is 2. Smaller than means we shade inside the circle, so this is the sketch. You have to label the center of the circle and make sure it's touching the y-axis because the radius is 2. We don't have to draw the blue and the green actually, but at least we have to draw this for the final answer. So we have a circle, label the center of the circle, make sure it is touching the y-axis, and we have the perpendicular bisector, label the x-intercept, y-intercept, and the intersection of the shaded area would be only this part for the shaded area. Okay, this value of arc z. So arc z means the argument of z, which means the angle theta here. So we are looking for this angle. The least value means, so the z can be from origin to any point on this area, on this shaded area, because we want the smallest angle. We want it to be exactly here when it's just touching this part here, so that the angle is as small as possible. So to find theta, we just look at this length here, because the radius, we know the radius is 2, and this center is, so this is 1 unit here, so this is 1 unit, which means if you draw this triangle here, this triangle here, this is 3 and this is 2, and so the theta is the inverse tangent 3/2. Alright, I'll see you again next time.